to talk about polygons and motions, rectangle, rhombi, and squares. Rectangle, rhombi, and squares. Please make note of both the location that you are watching this video, as well as the date and time that you are watching this video. Location and date and time. Let's recap what we've talked about so far. We've talked about parallelograms. And below is a parallelogram. You want to find all possible angles and solve for any variables. The minute you see the word parallelogram, you should remember the acronym OCD. OCD. And in this acronym, you should realize these items. You have opposite sides, which are parallel. We also have opposite sides congruent. Opposite angles, which are congruent. Consecutive angles, which are supplementary, and diagonals, which bisect each other. Knowing those 5 items, we're going to see what we can find. Let's start with the easiest. We trace these opposite sides. We know that they are congruent, which if one side's 16, this other side is 16. So 4x equals 16, x is going to equal 4. Let's see what else we can find. Opposite sides are also parallel. That means we can do this. We can do armpits of the Z. So if that's 39, this right here must also be 39 degrees. In addition to that, we know opposite angles are congruent. So right here, if this is 98, opposite angle must also be 98 degrees. And this one, which is often overlooked, is that consecutive angles are supplementary. Consecutive means angles that are next to each other. So this 98 and this angle right here have to add up to 180. So 180 minus 98, and we get 82. So this whole angle here is 82 degrees. We're going to subtract 39 from that, and we get 43. So this angle right here is now 43 degrees. And remember, opposite sides are parallel, so I can now draw an armpits of the Z going this way, alternate in, which means this angle up here is also going to be 43. So you can see when you know the OCD of parallelograms, you can find quite a deal of information. Now we're going to move on to 3 new shapes today. That's going to be rectangles, rhombi, and squares. So as a quick recap, what have we learned so far? We have learned that a parallelogram has 4 sides. And angles at some 360. We've also learned that opposite sides are parallel. Opposite sides congruent. Opposite angles congruent. Consecutive angles supplementary. And the last is that diagonals bisect each other. They go through each other's midpoints. Those are the qualities of a parallelogram. So I want you to imagine here, if you were to take a parallelogram and make all its corner angles to be 90, what shape would you get? If you said rectangle, you are correct. If you were to take these and make them all 90 degrees, and now if we were to draw this to scale, that would be a rectangle. So by definition, a rectangle is a parallelogram with 4 right angles. You take a parallelogram, make 4 right angles, you have a rectangle. Now you have a second shape. If you were to take the second shape here, and if you were to make, right now you can see in a regular parallelogram you have a longer side and a shorter side. In a parallelogram you have 2 elongated sides and 2 shorter sides. Imagine if you were to make all 4 sides exactly the same length. That would get you what's called a rhombus. A rhombus is a parallelogram with 4 equal sides. We need to change this to sides. Therefore, a rhombus is a parallelogram with 4 equal sides. So here we have a parallelogram, and both the rectangle and the rhombus are descendants of the parallelogram. They are parallelograms, so it's not a trick question. You need to be very careful, especially on SAT tests. If they ask you whether or not a rhombus or a rectangle are also parallelograms, the answer is yes. Both shapes are also parallelograms. But the rectangle and the rhombus have 2 additional characteristics. Besides the OCD characteristics of a of a parallelogram, there's 2 additional characteristics. So in a rectangle, you have the OCD qualities, opposite sides parallel, opposite angles congruent, and the like. But in addition, you have 4 right angles in the corner, 4 right corner angles. That's one additional quality. And the second additional quality is that this diagonal length and this diagonal length, not only do they cut each other in half, but they are of equal lengths. It's not the case in a parallelogram. In parallelogram, one diagonal is longer than the other. But here, you write the diagonal lengths themselves are congruent. Those are the 2 additional qualities of a rectangle. And in a rhombus, the 2 additional qualities, besides the OCD parallelogram qualities, the first additional quality is that the diagonals cut these corners, they bisect the corners in half. So the diagonals bisect the corners. That does not happen in a parallelogram nor a rectangle. So the diagonals bisect corner angles. And the second unique quality is that the diagonals themselves are perpendicular. In other words, they make a right angle on the inside. So those are the two additional unique qualities of both a rectangle and a rhombus. So here's your quad family tree. And in our quad family tree, we have the regular quad. This would be the parallelogram. And we already have these. It has 4 sides, angle, sum, 360. And then we have the OCD qualities. And then here we have a rectangle. And then here we have a rhombus. So in the rectangle, we have 4 sides, angle, sum, 360, plus the parallelogram, which is opposite sides parallel, opposite sides congruent, opposite angles congruent, consecutive angles supplementary, diagonals bisect each other. I know this is redundant, even though you're writing the same thing over and over again. It helps reinforce. So please do take the time to rewrite these sections. The rhombus has those same OCD qualities. So we call opposite sides parallel, opposite sides congruent, opposite angles congruent, consecutive angles supplementary, diagonals bisect each other. Again, those are all the same qualities of the parallelogram. Those are called the OCD qualities. Now, in addition to the rectangle has 2 additional triangles, which are the diagonal lengths congruent, and the fact that you have 4 right angles. Those are unique to a rectangle. Diagonal lengths congruent and 4 right angles. In a rhombus, the unique qualities are the fact that the diagonals are perpendicular. They make a right angle on the inside. Diagonals perpendicular. You also have diagonals which bisect opposite angles. They cut the corner angles in half. Now, if you watch carefully, both a rectangle and a rhombus combine to make a square. In other words, a square has all the qualities of both a rectangle and a rhombus. So a square is both a rectangle, rhombus, and a parallelogram combined. So here you have a parallelogram. A rectangle, and a rhombus, which are also parallelograms. And then a square is a rectangle, a square is a rhombus combined. So that shows the family relationship or the family qualities of these four quads. Now let's try some problems out with this information. It says in the rectangle, so we know it's a rectangle below, trace and mark all the given information on the diagram, find all possible angles and sides. So let's see what we have here. If this is a rectangle, we know that we have four sides, angles add up to 360, opposite sides parallel, opposite sides congruent, opposite angles congruent, consecutive angles supplementary, and diagonals that bisect each other. We also know the diagonal lengths are equal and you have four right angles. So let's get our information on here and see what we can do. We are told if we know that the diagonals bisect each other, that means they go through each other's middle, and the diagonals are equal in length to begin with. We know that this length, F to H, is exactly the same length as E all the way to G. Plus they cut each other in half, which means we're going to create four congruent pieces here. That's an important piece of information. Four congruent pieces. Now let's see what our given information is. We are told that E to I is 2x plus 1. We're also told F all the way to H, all the way, is going to be 3x plus 10. And last, we want to trace this, IFG, so we start at I, we go to F, we go to G, that this angle right here is 51 degrees. We're going to find everything that we can. Let's work with our side lengths first. Let's ask ourselves, what do we know about EI and FH? If you look very carefully, they are not equal. That's very important that you're not too hasty with that. These segments here are not equal. But what we do know, because that in the middle is a midpoint at I, we know that 2 EIs equals 1 FH. 2 EIs equals 1 FH. So we can set up an equation like this. 2 times e to I, which is 2x plus 1, equals FH, which is going to be 3x plus 10. We distribute. We're going to end up with 4x plus 2 equals 3x plus 10. We solve for x here and we get x equals 8. Now let's plug it in and see what happens. If we have x equals 8, up here we're going to have 2 times 8 plus 1, that's going to be 17. That means e to I equals 17. And here we have 3 times 8 plus 10. That's going to be 24. That's going to be 34. So that's going to be F to H is 34. And if you look very closely, 34 is exactly twice of 17. So that is a true statement here. So now we have found those lengths. What else can we find? Well, if you look very carefully, we have a pair of isosceles triangles here. And if we have isosceles triangles, that implies if you have two equal sides, you have two equal angles. So if this is 51, this is 51. And if we add 51 and 51, you get 102. Take it away from 180, and we're going to get this angle on the inside, right here, is going to be 78. And if that's 78, we can go like this and make a linear pair, which is 180. And that means this angle right here is 102. This angle, vertical to that, is going to be 78. And this angle right here is 102. Since we have 90 degrees here, we can take 90 minus 51, and we get 39. And then if we have, again, 2 equal sides, 2 equal angles, that means this is 39, which take that away from 90, which makes this 51, which makes this also 51, and this over here is going to be 39 as well, and 39. So we see that we can find quite a lot just knowing that we have a right triangle. Now there's one additional step, since we just learned about right angles, that we can actually take here. Watch very closely and you'll recognize what's going on. We have right here a right triangle. Let me pull it out. And we found already that this is 34. We have a right angle. We have 39 degrees there. We can actually solve for the side lengths as well. If I want x, I know this is opposite over hypo, so I can do sine of 39 equals x over 34. And to get y, that's going to be adjacent, so I can do cosine 39 equals x over 34. And I can solve for my side lengths there. So we're going to do 34. Actually, it's going to be 39 sine first times 34. That's going to give us 21.4. So our x is going to be 21.4. And our y length is going to be 39 cosine times 34. And that gives us 26.4. Obviously, we can see that this side is longer than that. So there is a lot of information that you can find when all you know is that you have a rectangle. Let's try one more, and we'll be done. So now we have a rhombus, and in a rhombus, we have all of these qualities to work with. So we have the OCD qualities, plus the fact that the diagonals are perpendicular and the diagonals bisect opposite sides. Let's see what we can do here. We are told that P to R is 10. So P all the way to R is 10. We're also told that Q to R is 13. So this is on the outside. Q to R is 13. And we know that the angle TQR is 23. TQR. We know that is 23. We're going to try to find everything that we can find. Well, remember, the first and most important quality of a rhombus, which is different than a rectangle, is that we have a right angle on the inside here. We also know that opposite sides, all four sides are equal. So if this is 13, this is 13, 13, and 13. The diagonals cut each other in half, so PT is 5 and TR is 5. Obviously, we are missing this right here, QT and TS. So I'm going to pull this triangle out so you can see it, so we can work with it. we have a right angle in the middle. We have here a 13. Here we have a 5. And we want to find, let's say we want to find t to s. So we can go 5 squared plus x squared equals 13 squared. We have x squared equals 144. We square root both sides. And that's a perfect square, which means this right here is going to be 12. That means t to s must be 12, and q to t must also be 12. So now we have all the sides. Let's see what we can do with the angles. Remember, the diagonals bisect opposite angles. So if this is 23, that means over here is 23. And since opposite angles are also equal, we're going to have 23 and 23 here. Again, we have a right angle. That's 23, so we can do this. We can go 180 minus 90 and minus 23, and we get 67. That's going to give us this angle right here, 67, which is also 67, 67, and 67. So once again, just by giving one little piece of information, the fact that we have a rhombus, there is a lot of information that you can squeeze out of the diagram.